Welcome and thank you for the time spent to come and listen to this talk. I'm here to tell you about a project that our company's been involved in for some time, and that is to print extremely large models and make them as useful as possible. We have a company in the Middle East called MCS, part of the Intragulf group of companies. We're based in Bahrain, but we service the Middle East. And first of all, I'd like to tell a little bit more about what we do. So our background is we specialize in data capture, and of course 3D laser scanning has become a methodology of choice, a means of rapidly gathering information accurately in great detail. We provide data processing services in-house, so this means creation of 3D CAD models, drawings, GIS content. We're involved in data management, whether it's document or engineering type data, and data publishing. So traditionally, of course, this is maps, renderings, animations, and more recently, the delivery of 3D physical models. So to us, it was very interesting to find 3D printing technologies that could be exploited for our types of data sources. A little bit more about the area. I'm sure you will recognize this part of the world, but you may not know Bahrain or its immediate vicinity. So Bahrain is nestled here, right in the middle of the Arabian Gulf, between Qatar Peninsula and the eastern coast of Saudi. It's very strategically positioned. It's right in the center of the Middle East. So it's a small island. It's about 70 kilometers long and about 15 wide. And there's a bridge that links us, one of the longest bridges in the world when it was built, between Bahrain and the eastern province of Saudi. So it's well positioned from a business point of view to deal with Saudi Arabia. And there's plans afoot to build a bridge from Bahrain across to Qatar. We chose and elected to use the printers from MCore. At the moment we're printing or reprinting the Bahrain Island using the MCore Iris, which is a color version of the printer. But the map that I'll be showing you details on was produced using the MCore Matrix, which is the plain paper printer. Bahrain, as I said, I just mentioned the dimensions of Bahrain. The scale suited to producing Bahrain turned out to be close to 1 to 10,000. So we stuck to a traditional scale, 1 to 10,000. So obviously this resulted in a model being about 7 meters long and half as wide. The build envelope for the printer is just under the size of A4. It produces its prints from plain paper, and we chose 150 millimeter by 250 millimeter, which gave us the opportunity of producing tiles covering a land mass area of 1.5 kilometer by 2.5 kilometers. And you can see on the left here the grid of tiles that we need to cover the whole land area. Here's some statistics for the project. To the right here, you can see that to achieve total land coverage on a model of this size, we needed 325 tiles, and that consumed 25,000 sheets of paper. We're using 80 gram per square meter paper, which means that we have a step resolution within the print build of just about 0.1 of a millimeter. So it's quite a high resolution, but the key thing here, as I'm pointing out at the bottom, is that the material cost is between 10 and 15% of any other materials that we could be using in any other 3D printing technology that could potentially build a model of this size. So this is a financial practicality, allowed us to do the experimentation needed to ensure a successful project. A few other statistics here. The sheets of paper are obviously glued automatically by the printer, and we consume 26 liters of glue to build all of these tiles. The tungsten carbide blade that's used to cut each layer to the appropriate profile traveled 111 kilometers, if you can imagine it, to cover all of these layers within each of these tiles. Total build volume, as mentioned down here, is 54 liters. That's 54 liters of paper, which obviously is the volume from the original 52 reams of paper consumed by the printer. A bit more information on the build time. This is the actual time the machine took to build the model. An awful lot more time was spent in preparing the supporting 3D CAD information, the digital information needed to drive the printer. And I'm going to talk a little bit more about that in a minute. Different tiles took different periods of time to print, but in total, that's the amount of print time that was needed. Here's a few photographs to give you an idea of what the model looks like. It's, as I say, 7 meters long, so it's difficult to photograph without a fisheye lens. I've got a video at the end that gives you a better perspective of the finished product. As I said earlier, the first model we've done is printed in plain paper, so it's very difficult to identify features such as the road network. So we used the same printer to print a layer of, we used grey paper within the printer to print the road layer, and we glued the road layer back onto the train. So even with the monochrome approach, we're able to get an interesting looking relief map. This is the built-up area in the north. Here's a photograph taken from one of the taller buildings in Bahrain, the Bahrain Financial Harbour. And we're looking across at the Bahrain World Trade Center towers, and you can see the density of buildings within the capital, Manama. Here's a view of some of the tiles where we've done full 3D printing, including all of the buildings, as opposed to just the train model itself. That photograph was taken from the top of this tower, looking down towards the World Trade Center towers over here. Here is a well-known feature within Bahrain, the Formula One track. We have, as I say, a process in place now where we're redoing this model using the full color version of the printer, and you can see a huge improvement. While this is still interesting when you look at it in the flesh, the details are limited to the road network and the train itself, the relief of the land. Whereas this is the plan view of the full colored tile. There's a perspective view of the same tile, so you can see that we don't really need to worry about trying to model or obtain detail of features that are well covered with the coloration that the satellite image was providing us. Another initiative that we're in process with is collaboration with a company called Seeable. And Seeable produce augmented reality apps, allowing you to use your smartphone or your tablet's camera to identify your location and to bring up information relative to that geo-positioning. So why not take your 3D model of a country, in the case of Bahrain, encode it so that you can use augmented reality apps to stand around your physical table and bring up information related to that space. So it's an interesting concept, and we hope to have more information on that out very soon. So here is a colleague of mine using his tab. I think it's a Galaxy tab. It could be an iPhone or any smart device. And he's able to bring up a virtual reality model at the location of the physical map he's looking at. So it's a great communication or collaboration tool. So talking you through the process in a little bit more in detail, here's an area of Bahrain, courtesy of Google. Apparently we need to refer to this. They are very helpful. They do provide us lots of great imagery. And you'll see over here, I hope it's clear enough on the projected screen, myriads of oil wells. And over here we've got the Grand Prix circuit. This is the tiles that I showed earlier. This is how we break down that area into manageable, printable pieces. And this is the source data, which is spot heights over a grid, break lines. This has been gathered from mobile mapping systems. We're working with some leading companies that are bringing this technology forward. It's becoming so much cheaper and incredibly accurate, so there's no excuse now for anyone to not be able to gather the information they need to produce the models, either digital or physical. And this is the same data processed into a mesh. In the far corner here you can see the coastline. We obviously had to provide a thickness, so the model actually starts from about 20 meters below surface, so that we're able to have the sea shown within the model. We will be getting some hydrographic data, and the next coloured model will actually have the seabed all around the coastline of Bahrain shown within the 3D physical model as well. Here's the rendered view, and you might notice that one of the problems we faced is that Bahrain's quite flat. So it did create a dilemma, because we accurately replicated Bahrain, and with a lot of our test tiles we realized that it simply wasn't interesting enough. The other problem is that as you can appreciate, when you're looking at a model, you're obviously looking down at it at about 45 degrees, and sometimes even more steeply. So a lot of the depth perspective you get is lost. And we experimented with exaggerating the Z, the elevation levels within the model, and came up for some reason with a factor of 2.7, gave us a much more realistic looking model without it becoming too stretched. It seemed to, for some reason, be a happy exaggeration level. So there's the standard terrain. This is a rim rock, so there are some features that stand out in Bahrain, and that's what it looks like exaggerated 2.7 times. You can see it doesn't make it look outrageously big. It didn't create too many spikes, but it becomes that much more visible. Here are our tiles, and I'm just stepping through the process, cutting out a tile, exaggerating the Z. We'll take a closer look at that. This, of course, is just a skin, and we came up with methodologies for converting basically this digital terrain model, this surface layer, into a physical watertight object, which is of course what's needed to drive a 3D printer. A closer view, and this is the finished tile. This is the, if you like, the physical block for that part of Bahrain's terrain. Now I'm showing how we drape an image. The printer comes with two software packages. Slice It, which cuts this solid object as it now is, this tile, into the requisite layers to provide the machine code needed to drive the printer, and Color It, which provides you with tools and functions to position and drape the imagery correctly over the physical model. Here is the adjacent tile, and with the draped image over the top, you get a seamless approach. You can see the level of detail that's achievable. There's simply no need to worry about picking up elevations in this plantation, for example, when the color is going to give you the impression of relief. But the rim rock itself, now that it's exaggerated, very much needs to be printed with physical relief. Here's a different perspective of the same area. You can see that on this runway, we're actually picking up the runway markings or the taxiway markings, and the clarity of color 3D printing makes a huge difference. You'll see over here, I hope it shows up all right, yeah, that these are oil sumps, and of course because you've got little ponds of black oil within these sumps, they stand out very well. So even at a scale of 1 to 10,000, an enormous amount of country features can be looked at and used within the normal discussions about how best to exploit this land. Okay, this is the build platform, the print environment. So we bring the 3D model into this environment and run Slice It, the tool used to slice the model up. And it computes where, being a paper printer, the glue will be laid down between each successive sheet of paper. Every sheet of paper gets dragged across the pre-glued surface, and then the build platform is raised to the ceiling of the printer with a worm drive. It exerts a 1-ton press against a heated plate. So each consecutive sheet of paper is bonded together extremely well. The glue soaks into the paper, and you end up with a piece of wood from which you pull away the waste, the pieces you don't need, leaving the solid model. So that's the base layer. Always have a nice thick base on which to build your model. And these are consecutive layers, so you can see that only the area that's needed is covered with the glue required. I'll take a slightly closer look at that so that you can see what I mean. In this particular area, there's the base, And here is the area on whichever layer number that might be, maybe layer 100. And here are the little dots of glue that are laid down on each sheet. So all of these green dots indicate the glue has been put down, but to a lesser degree. And you might ask, well, why would you bother gluing the area that's going to be removed? Well, that's purely so that you can remove big parts of it. Likewise, the brown lines indicate where the knife blade, the tungsten carbide blade, will travel, cutting the silhouette. It just cuts through that single layer of paper, but you still end up with a block from which you weed the waste material. So it still cuts rectangular shapes in these areas, even though there'll be waste, so that you can pull off blocks of material very rapidly. There's an animation of the layers required to make up that particular tile. It looks a lot better in color, so I'll just move to the next slide. So that's the iterative process the software goes through. And provided there aren't any errors with the solid model, you can now immediately send this model to the printer. The other good thing is that the software provides statistics on every single build. So the yellow line here relates to this particular tile, and the build time, of course, is the important factor to us. Obviously, longer builds, 11-hour build, for example, would be set off as people leave work and picked up in the morning. And shorter builds need to be carried out during the day when there's someone on hand to obviously change the prints out on a regular basis. Statistics for each build are available, so there's no excuse for your support staff to not ensure that they have the materials on hand for the next week's work. This is a more elevated tile. I won't bore you with the statistics, but at the end of the day, you can see this one tile alone took 23 hours to build, but it's quite tall, very, very detailed, and the blade traveled 1.6 kilometers to cut out all of those successive layers. Here's just another sheet of statistics that we used for planning the project. We were able to finish the modeling of all 300 odd tiles and come up with a program as which area to print first. That's the tile from that particular area shown earlier. And I've now got two very short videos because the photographs don't really show the extent of the model. So there's the model, there's the printer in the background in its enclosure. And I'm simply walking. I have to excuse the low quality of this video, but it hopefully gives you an idea of the extent of the physical build. So it's the southern tip of Bahrain, just walking up the west coast. The green areas have actually been coloured in on this first model, but as I was explaining, the coloured model will ensure that we actually have a photorealistic effect of the whole model. The camera's just being brought around now to simulate an approach to Maharak or Bahrain Airport, if anyone's been there. But we just now move around to the north part of the island to show the effect you get with the printed buildings right in the capital area. It's just another short video that shows the plan view. It's been used, a lot of the ministries now use this as a communication tool. They find it an awful lot easier to pore over a physical 3D model than they do paper drawings. And of course, if they have data in digital format, proposals, not just existing structure, can be printed. In reality, the depth of the road is exaggerated so it stands out, but you can see that even complex junctions like that can be shown very clearly in 3D. Right, I'd like to thank you again for your time.